Our last job with sinusoidal graphs is to be able to look at a graph and backtrack until we get to the function that created this graph. And the funny thing about sinusoids that we've already covered before is there are an infinite number of equations that would work for you, provided you set the phase shift correctly. Okay, so if you have a version of this question where it only says, it doesn't say any of this stuff right here, and all it says is give the function, you can pick a positive sign, a negative sign, a positive cosine, a negative cosine. Any of those will work as long as you select all your phase shifts correctly, depending on the function that you do. I'm going to go through this example where it asks for each one, and using this, you would be able to pick your choice of any of these functions if you had the freedom to choose whatever equation you wanted. Now, in this example, we don't really have that freedom. It wants a positive sine function, a positive cosine, and so on. So let's start by finding the things that are not going to change. And by that, I mean, what doesn't care about phase shift? What doesn't care? We have midline right here, middle of the graph. That's k equals -1. And I can see that this has an amplitude of 4. Okay, so a equals 4. These are not going to change whether it's a positive sine or a negative cosine. They don't care. The period is another thing that doesn't care about the phase shift. What is the period of this graph? Well, there's a couple ways you can figure it out, and they all tend to be they all have the same idea. We're going to look for where the function repeats itself. And you can either pick the top of the curve to another top of the curve and ask what's the distance between them. I like to go for easier calculations. I like to look at the y equals 0, or the x equals 0 point, the y-intercept, and say, where does it touch that point again? And in this case, I see that over here at pi. So I would say, what's wrong with what I just did? Okay, take a second. What's wrong with what I just did here? It has the same y value, but it's not the repeat function, because at this point, it's going down. At this point over here, it's going up. Okay, so really, this isn't going to work. We would need to say, where's another place where it's matching the exact behavior? Okay, that is going to be same value going down. Okay, see, now that's a good repeat. And I see that the distance between these is 4 pi over 3. Period is 4 pi over 3, right? Right here. And if you have a point that you're starting with, like right there, that's not on the y-axis, then you just take the point where it ends, subtract the point where it begins. That's the length of your period. Okay, so if p is 4 pi over 3, remember what that equals. That's 2 pi over b. And you can solve this equation. A little math. What do we get here? I think that's b equals 3/2. And you can go through the division algebra if you want. Am I right? Pretty sure I'm right. Okay. Now, I know k, a, and b. Those are all very important for the equation. I don't know h yet. That's the last thing I need. So let's just write down this function notation, the function, the general form of the trig function that I'm going to be writing these variables into. It's a. In our case, we're looking for a positive sine function, so I'm going to start with sine. It's a times sine of b times x minus h plus k. All right, that's our function. So what I'm going to do is substitute these values in and get a working equation that gets me almost all the way there. This is going to be 4 sine, remember I wanted a positive sine, times 3/2 x minus, I don't know yet, we'll get to that, plus k. What was k? -1. Great. So that'll be -1. Okay, now this right here is the important one. I'm going to get rid of this guy because you all have that memorized. You don't need to see it. We're going to move this over, I guess here. That's the best I can do. And now, this is basically what you're going to type in for the positive sine function right here. We just need to figure out what that phase shift is. Well, where in this graph do you see a positive sine function? Take a look. It has to cross the midline. Okay, all sine functions start at the midline. And it's positive at this point right here. So that is, well, whatever this value is. which is halfway between negative pi over 3 and negative 2 pi over 3. You can think of these as negative 2 pi over 6 and negative 4 pi over 6. That might make it easier. Halfway in between those is negative 3 pi over 6. So negative 3 pi over 6, that's our phase shift. And we would put that in here. Don't forget your sign flip. So that's our equation. This is our first one right there. Now, how would we turn that into a, let's just use negative sine for a moment. Okay, we'll skip over to number 3. You would look for the place in this graph where a negative sine function is starting. Okay, so let's get rid of these things we just drew here. Blah, 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 go away. And I would like the midline up here. I see a negative sine function starting right here, and it goes down. And that, halfway between 0 and pi over 3, that's pi over 6. So there's a phase shift of pi over 6 if I have a negative 4 sine function. This is the negative sine function. You see all that's changed is the amplitude and the phase shift. The amplitude didn't change. The sign of the sine function, the plus or minus sign in front, that's what changed. So we have to make sure we're starting at the right place with the phase shift. Okay, so this guy would go here. And we can do the same thing for cosine. For cosine, we're just going to change this to, let's do the positive cosine. All the other stuff stays the same. And what is the phase shift for positive cosine? Well, you go into your graph. There it is, right there. That's my positive cosine. So that starts at, what is this? Negative pi over 6. Okay, halfway between 0 and negative pi over 3. That must be negative pi over 6. So this is going to be plus pi over 6. Don't forget your sign flip. Okay, and so on and so on. You see, most of our work was done when we figured out these things. All we have to do for all these different equations, it looks like 4 times the work, but really we're just repeating ourselves, finding different phase shifts in this graph. Okay, right? The positive sine, the positive cosine, the negative sine, and the negative cosine.